Hello, everyone. Welcome to today's virtual workshop on Build with DocumentDB with MongoDB compatibility. My name is Meet Bagdev. I'm a senior product manager working on DocumentDB. For today's workshop, we will go through few things, starting with how to get started with DocumentDB. In this, we will cover how to create your first DocumentDB cluster, connect to it from popular tools such as the Mongo shell, and popular programming languages such as Python. Once you've done that and kind of gotten the hang of how to get started, we'll move on to exploring some management capabilities. Specifically, we will talk about how to scale your DocumentDB clusters. Next, we'll move on to talking about how DocumentDB integrates with other AWS services such as Lambda, Aurora, Elasticsearch, Glue, and Athena. Last but not the least, we'll cover data modeling patterns and talk about some best practices when it comes to modeling your JSON data for DocumentDB. And then we'll wrap it up with questions and answers. All right, let's get started. Before we dive into the content, I wanted to quickly level set on certain terms and nouns that are specific to DocumentDB and AWS. We'll talk about these as we go through the rest of the content. So just wanted to make sure that those are clear. And the first one is cluster. So a cluster in DocumentDB consists of 0 or more database instances and a cluster volume that manages the data for these instances. It is the primary entity that you'll go interact with from the console. So let's say you were to go to the console and go to DocumentDB, the first thing you'll do is create a DocumentDB cluster. Next, you have instances, and there's two types of instances, primary instances and replica instances. Instances, you can think of those as compute units and the processing power horse for your database. Depending on the type of instance, for instance, a primary instance will support both read and write operations, while the replica instance will only support read operations. Every cluster can have exactly and only one primary instance, while every cluster can have up to 15 replica instances. We also call replica instances read replicas. So if you hear me say read replicas, it's interchangeable with replica instances. And one of the cool things about replica instances is that they're automatically promoted to a primary in the event of a failure. Cluster volume is the durable storage service layer that sits underneath the instances. The data in your cluster volume is replicated 6 ways across 3 different AWS availability zones. The cluster volume is very durable and reliable, and we take data loss very seriously, so you can be rest assured that your data is safe with the way our cluster volume is architected. Next, you have endpoints. There's 3 types of endpoints in DocumentDB. An endpoint is essentially the DNS that you connect to. So the first one is the cluster endpoint, which is the cluster's primary instance endpoint, and every cluster can only have one cluster endpoint. Next, you have reader endpoints. The reader endpoint is a connection endpoint that connects to one of the replicas for your cluster. If your cluster has multiple replicas, then the reader endpoint will connect to any of those available replicas in round-robin fashion, I believe. And the last one is instance endpoint. So the instance endpoint is specific to each instance in your DocumentDB cluster. So for instance, if you have 15 DocumentDB instances, then you'll have 15 instance endpoints. The last 2 are AWS concepts, which are VPC and security groups. So VPC is essentially a virtual private network that is dedicated to your AWS account. You're essentially carving out a network in the AWS network and then controlling access to it. And then security group, you can think of that as a virtual firewall. So if you're thinking about opening up certain ports or closing down certain ports or accepting traffic from certain IP addresses or blocking traffic from certain IP addresses, all of those controls are actioned through the security group. All right. So this diagram essentially summarizes the things that I talked about. If you were to look at it from an architecture point of view, you have the storage, the cluster volume, which is the storage layer. This is distributed across your instance endpoints. And then you'll have a primary instance, which is right here, and you have exactly one of those. The primary instance is associated with the cluster endpoint, and it also has its own instance endpoint. And then you have replica instances. In this diagram, I have 2, but you can have up to 15, and each replica instance also has its own instance endpoint, or you can connect to either one of them using a reader endpoint. All right, let's move on. So when we talk about DocumentDB and building with DocumentDB, one of the first things that we often hear from our customers is, how do you get started with DocumentDB? So to get started with DocumentDB, you can create your first DocumentDB cluster, either from the AWS Management Console, the AWS CLI, or use an existing AWS CloudFormation template for DocumentDB. They all have their own purposes. Some folks like to use a CLI more, some folks like to use the GUI, while some others want to templatize deployment across the board. For the purposes of this workshop, I'll show you guys how you can create a DocumentDB cluster from the management console and connect to it using the Mongo shell from AWS Cloud9. And I'll talk about what Cloud9 is also in just a bit. So first things first, let's head over to the console. So here I am in the AWS Management Console, and to create my first DocumentDB cluster, I'll just go to the search box here, search for DocumentDB, and it'll take me to the screen where I'll get to see the existing clusters that I have. Right now I have one cluster. If you didn't have any clusters, you'd obviously see none. But to create a new one, you go ahead and hit this create button. So once you do that, you have to give your cluster a name, a unique identifier. So I'm gonna just call this Virtual Workshop Cluster Test. Next, you specify an instance class. The way to think about this is these are essentially your SKUs for your instance. The smallest one we support is a 2 vCPU 16 gigabyte RAM instance, which is an R5 large. And the largest one we support is a 96 vCPU instance with 768 gigs of RAM, which is our R5 24X large. We also have R4 instances, which are the previous hardware generation instance SKUs. Typically, for almost all scenarios, we recommend customers to use the R4 SKU over the R4 SKU, because with R4, you're getting more performance for the price that you're paying. So essentially, if you're not using R5, you're very likely leaving some price performance or just money on the table. So purposes of this demo, I'm going to go ahead and choose the smallest one. And I'm gonna say I would like to create this cluster with 3 instances, where one of them is my primary and the other 2 are the replicas, which are the secondaries. Next, I specify a username and a password. And then you get to see the estimated cost for what your cluster of 3 instances will cost. Obviously, there's specifics around how IOPS, storage, and backups and data transfer is charged. For that, we have links out from our create page, but this is essentially a good estimate for you to get a ballpark as to how much this is going to cost you. At this point, you have the option to create the cluster with the defaults we have, or you can toggle the switch for show advanced settings, and then you'll get to see some of our network specific settings, such as the network settings, cluster options, etc. So here you can pick the VPC you would like to provision the cluster in, and the subnet group and different VPC security groups. I only have one here, so I'm just going to choose my default VPC, my default subnet, and my default security group. When you select a security group, make sure that you are opening up the port that you'll specify very soon inside of your security group. Otherwise, applications will not be able to connect to your DocumentDB cluster. I'd already done this prior to this demo, But if you're doing this for the first time, make sure you make a note of that. Instructions for this can also be found in our documentation. So next you'll specify the port, and then you'll specify a cluster parameter group. I'm going with default, but if you've created your custom parameter groups, you can choose that as well. Moving down the list, you have the option to turn on encryption at rest. Actually, I stand corrected, it's turned on by default. So if you don't do anything, encryption is already turned on, and you can either use the default master key or bring your own. But this is one of those cool features that's available right out of the box. Next, you can specify a backup retention period. This could be anywhere between 1 and 35 days. This is important to customize when you create your cluster, because it'll give you an idea as to at what point can you do a point-in-time restore. For instance, if I set 7 days, this means a week from now, if something goes wrong and I want to revert my cluster back to how it was today at create time, I can do that. So specifying a retention period that works for you and your use case is extremely important. Just for today's workshop demo, I'm just going to select 7 days. Next, I can also specify a start time and a duration for the backup window. So I'm saying I would like my backups to schedule at midnight in a 30-minute time period. Moving down the list, we also give you the ability to export logs to CloudWatch. So we support 2 types of logs today, audit logs and profiler logs. Audit logs help you audit DDL events, while profiler logs help you audit and analyze slow-running queries and operations. So let's just say, go ahead and I'll select both of them. And the last one you get to customize is a maintenance window. This is one of my favorite features. Customers often ask us that, hey, how do I know when is AWS going to apply a patch on my cluster? Since DocumentDB is a fully managed service, we do take care of things such as security updates and patches under the hood, but we also give customers the ability to specify when they would like these to happen. So in this case, I know that my workload is pretty light on Saturday at about 1 a.m. for 30 minutes. So I'm going to go ahead and specify that as my maintenance window. And that way, when the DocumentDB team applies any patches, it always goes through in that window. And we'll also notify you before the patch is being applied that's essentially, that's the window that they'll come through. So we typically notify customers via email. The last one is you can add tags. So for instance, I can say, if this is my dev instance, I can add a key saying usage, and I can just say dev. This means that this is just a dev instance. If I have another cluster, if I have a prod cluster, I can do the same by adding another tag for prod. And last but not the least, I've turned on deletion protection. This is important because it helps protect your cluster from accidental deletes. So if someone just clicks a delete button from the console, since you have delete protection turned on, you won't be able to delete your cluster. You'd have to go turn this off, and then you'll be able to delete your cluster, which is good because it helps from any oops kind of scenarios. So now that we've inputted all the information we need, let's go ahead and create our cluster. So at this point, we're spinning up a DocumentDB cluster in the region of your choice, which is in Ohio in this case. It takes a couple of minutes for the cluster to come up. In interest of time, I'll just go ahead and connect to one of my existing clusters to show you what that experience looks like. So I already had a cluster that I previously created. It's called test cluster. When I click on it, I get to see 4 tabs, and under the first one, we get to see the connection string for any DocumentDB cluster for both the Mongo shell and client applications. For instance, let's say you're connecting from Python or Node.js or such. So since I want to connect to it from my Mongo shell, I'm going to go ahead and copy this command. And then I'm going to head over to Cloud9. So here I am in Cloud9. For folks who don't know, Cloud9 is an integrated terminal built right into the browser, which is really great because it's A, is a terminal in the browser, and B, it's very easy for developers to get started, especially if you're trying to interact with AWS resources inside of a VPC. So DocumentDB is one of those resources that can only be accessed from inside a VPC, which means your client application also needs to live inside of a VPC. There are ways to do it outside of a VPC using an SSH tunnel, and we'll cover that later. But for production applications, we typically recommend customers use DocumentDB from inside of a VPC as the security best practice. So here I am, launched my Cloud9 environment. Now I'm ready to, I have a terminal right here, and I'm ready to start connecting to my cluster. So I'm just gonna go ahead and copy the Mongo shell connection string. I hit enter. It's asking me for my password. And there you go. I successfully connected to my DocumentDB cluster from the Mongo shell. Now I can run commands such as db version. So it tells me that I'm running Mongo 3.6. I can also do some more fun stuff. For instance, I'm going to go ahead and insert a document now. So let's go ahead and copy this query. And I'm inserting a document, which is just a product document for bread in this case, where we keep information such as the vendor, stock, and the price for it. I go ahead and hit enter, and it tells me that I've successfully inserted that record. Now I can also go ahead and find the record. So let's go ahead and find it right here. And there you go. We were successfully able to find our document as well. So now just like any other query, basically with the shell, you can write any other queries to work against your DocumentDB cluster. DocumentDB is wire compatible with MongoDB, so all existing Mongo tools just continue to work with DocumentDB the same way you would expect them to work with MongoDB. All right, moving on. In addition to connecting from the shell, we often get questions from our customers on how can they connect to DocumentDB from programming languages, such as Python, Node.js, PHP, etc. The DocumentDB is compatible with existing MongoDB client drivers for all popular languages. And we document the connection strings in our docs. Let me quickly open this link. And if I scroll down further on this page, you'll see connection strings for all languages, for instance, Python, Node.js, PHP, Go, Java, etc. Let's actually do a demo here. So if I go back to my Cloud9 environment, I wanted to show you guys a Python sample that I have. So I've written a Python sample that takes 3 JSON documents about Big Bang Theory, which is one of my favorite TV shows, which is essentially just metadata about each of the episodes. I have 3 episodes here, season 1, episode 1, 2, and 3. And in each document, I have some sample fields such as the ID of the document, URL, name, how long is it, a summary, etc. So in my Python sample, all I'm going to do is I'm going to go ahead and connect to my cluster with the username and password that I specified at create time. So SSL by default is always turned on. So we'll go ahead and say mark true. And if you do turn on SSL, you also need a CA certificate to connect your DocumentDB cluster. And the steps to download that CA certificate are also on the same page where you get to see the connection strings. So we essentially put them in an S3 bucket called RDS downloads. So you can download it from there. And once you've downloaded your CA certificate, you just punch that into the connection string. And in my Python sample, I'm going to go ahead and insert the 3 documents, search for one of them by specifying the name of the episode, which is the Big Bang hypothesis in this case. And I'm going to go ahead and update that document and give it a review of 5 stars. So first things first, let's go ahead and export our cluster name. So I have an environment variable called cluster name. So I'm going to go ahead and get the cluster name of the cluster that we just created. As you can see, the cluster that we just created is now available. So I'm going to go ahead and get the cluster endpoint. And then I'm also going to export my environment variables, which have the username and password. So now that I've done that, I can go ahead and connect to my Python sample. And there you go. It tells me I've successfully inserted the data into my new DocumentDB cluster. I ran a search query to find the document where the name of the episode was the Big Brown Hypothesis, which is right here. And then I added a 5-star review to it. So as you can see, the review field is now showing up. So going back to our content today, in addition to connecting from the Mongo shell and client drivers, we often hear from customers that they would like to connect to DocumentDB from their local laptop or their client machine, which live outside of an AWS VPC. So like I mentioned, DocumentDB by itself is a VPC-only service. But if you do want to connect to DocumentDB from outside your VPC for dev test purposes, you can use an EC2 instance as a jump box. So once you've created your EC2 instance, you can set up an SSH tunnel to your DocumentDB cluster from the instance. And your EC2 instance, if you configure it in a way that it's available to the public internet, you can connect to your EC2 instance from outside the VPC. So in this case, if you see you have an application outside your VPC which can talk to your EC2 instance, your EC2 instance in turn can talk to your DocumentDB cluster. Thus, by setting up an SSH tunnel end-to-end, you're able to connect your DocumentDB cluster from your client machine. To set up an SSH tunnel, you need to run a command like this, where first you specify the private key or the password of your EC2 instance. Then you specify the endpoint of your DocumentDB cluster. And then you specify the public DNS endpoint prepended by the username of your EC2 instance. So let's just go ahead and give that a shot and see how that works from my laptop. All right, so here I am in the terminal, and the first thing I'm going to do is I'm going to go ahead and create an SSH tunnel between my DocumentDB cluster and my EC2 instance that I've already created inside the same VPC as my DocumentDB cluster. So I'm going to go ahead and go back to the browser and grab my DocumentDB cluster's endpoint. I'm going to punch that in here. And then I'll hit enter. So at this point, we've created an SSH tunnel. Nothing on the screen is going to get printed. So if you're trying this on your machine, when you run this command, if you don't see anything on the screen, that's fine. That doesn't mean that there's something wrong. Now, if I go to another terminal shell, I'm going to use the Mongo shell to connect to my DocumentDB cluster. And all I need to do is specify SSL/TLS. So since TLS was turned on when we created the cluster, I'm going to go ahead and specify that as a part of my connection string. And just like before, we need to specify the path for the CA certificate. And then we specified the username, which was DocDB admin. I'm going to go ahead and hit enter. It's going to ask me for my password, which I just provided. And there you go. We just connected to our DocumentDB cluster from my local laptop using an SSH tunnel. Now I can run queries such as db.version and essentially anything you could do from my previous Cloud9 environment, you can also do from your local laptop, which is outside your VPC. One caveat here is that SSH tunnel did not support connecting to your DocumentDB cluster as a replica set. So if you're doing this for a production environment, there are some risks associated, especially if there's any sort of failovers or restarts. So we don't recommend using SSH tunnel for production applications. A, because you're connecting to your DocumentDB cluster over the public internet, and B, there's no way to connect your DocumentDB cluster as a replica set. All right, so let's go back to our content here. In addition to connecting to DocumentDB cluster from tools and drivers, we often hear from customers whether DocumentDB is compatible with existing Mongo GUI tools. So the short answer is yes. All popular MongoDB GUI tools such as Robo3T, Studio 3T, Compass, and Mongo Booster all work with DocumentDB. Most of the times folks like to use a GUI tool over a shell because they prefer the visual interface, or if they just want to run simple ad hoc queries or visually explore their data and schema. So that's where GUI tools come in. And like I mentioned, DocumentDB is compatible with existing GUI tools. So for purposes of today's workshop, I'll do a demo on how to connect to DocumentDB from Robo3T. So for folks who don't know, Robo3T is essentially, or was previously known as RoboMongo. It's one of the most popular open source free GUI tools to interact against DocumentDB and MongoDB. So for this demo, I'll just show you what you would need to do if you were connecting to your cluster, your DocumentDB cluster from Robo3T. So first things first, I'm going to go ahead and open up Robo3T. Here I already have an endpoint, so I'll show you connection, sorry. So I'll show you what I had to do to set that up. So when you go ahead and add a new connection in Robo3T, it'll ask you for your address, your host address. So I'm gonna go ahead and fetch that from my cluster. So let's go ahead and grab the cluster endpoint. I'm gonna punch that in there. Then it asks you for authentication. So here you specify your username and your password, and for auth mechanism, we're gonna go with the default here. And then the database name. So if this is your first time connecting to your cluster and you don't have any other databases that you created, then just go ahead and just use test or testDB or any other database name that you'd like to create on connect time. If you've already created your first database, then you can go ahead and create to the admin database to get global access across all your databases. For demo purposes, I'm just gonna go ahead and use testDB. Next, since I'm doing this from my laptop, I need to set up an SSH tunnel here. So I'm gonna go ahead and check box use SSH tunnel. Robo3T is pretty cool because it lets you set an SSH tunnel right in the GUI. So all I need to specify is my EC2 DNS address of my instance, specify the port number, the username, and the private key to my EC2 instance. Next, since my cluster has SSL turned on, I'm going to go ahead and check yes for use SSL protocol, and I'm going to provide the path to my CA certificate file, which is the RDS combined CA bundle.pem file. I will also go ahead and check the advanced options checkbox because I need to go ahead and change the invalid settings dropdown to allowed. Once I've done that, I'm all set and I can now connect to my DocumentDB cluster from Robo3T. To do this, I'm gonna go ahead and hit test. It's essentially testing our connection, and as you can see, we were able to connect to our EC2 instance, create the tunnel over our DocumentDB cluster, and our credentials were correct, so we were authorized on our database. Now I can go ahead and hit save, and if I go ahead and click here, which is the connect button, you'll see that I'm connected to my new DocumentDB cluster that I just created a few minutes ago. I don't have any collections right now, so let's go ahead and create a collection. Let's call it test collection. And I can also insert some data into this. So let's say I'm gonna insert name, gonna insert my name here. I'll validate that this is a valid JSON document, and I hit save. And I just inserted my first document in there, and I can also view all my data inside of my collection And as you can see, the document that we just inserted was successfully inserted, and I can view it using the find command. So that concludes that demo on how to connect to DocumentDB using GUI tools such as Robo3T. Similar setup also works for other GUI tools such as Studio 3T and Compass and Mongo Booster, and I'm sure I'm leaving a few off, but essentially you can follow similar steps to establish a connection from your favorite GUI tool. All right, moving on. So I mentioned replica sets a little bit a few minutes back. Replica sets is essentially a group of instances which are of the primary, X primary and Y secondary kind of nature, right, where you'll have one primary and a few other secondaries. The reason we recommend our customers to connect to their cluster as a replica set for production applications is because it helps distribute reads to the replica instances using a driver's built-in read preference capabilities. So essentially any read traffic coming into your cluster, you would ideally want to send it to one of your replica instances, while the write traffic you'd like to keep sending it to your primary instance. It's also really useful for failover scenarios where, let's say, you have one primary instance and two replica instances, and your primary instance were to go down. We will fail over one of your secondary instances and promote it to a primary instance, thereby making sure your application is still able to function without much downtime. If you did not create multiple instances and did not connect to your DocumentDB cluster as a replica set, and if you were only connecting to your DocumentDB cluster with an instance endpoint, and if that instance were to go down, we would not be able to fail you over because you're connected to an instance without the use of replica sets. So as a general best practice, we recommend that you use replica sets. Even specifically with replica sets, we recommend that you use the read preference. You set the read preference attribute to secondary preferred. What this does is that it routes all the read requests to your read replica instances, and it routes all the write requests to your primary instance. This helps get you the best performance from your cluster by making sure primary is not getting overloaded, and it also just helps distribute the read load across multiple read replica instances. So we recommend this in our connection strings. If you were to just go to our console, you'll see that we set the read preference to secondary preferred. Let's look at it from a use case and how this really works. So in this case, I am connecting to my DocumentDB cluster of one primary instance and two replica instances using the secondary preferred connection string attribute. So any writes from my application are going to my primary instance, while any reads from my application are going to the replica instances. Obviously, under the hood, we have the distributed storage volume across different AZs with copies of your data. Now, let's say one of my replica instances were to go down. In that event, because you were using the secondary preferred connection string attribute and you were connected to your cluster with a replica set, your application does not see any impact or any downtime because of this, because you still have one primary instance where your writes are going and one replica instance where all your reads are going. Now, let's say in the event your replica instance were to also go down, your application will still route all the will now start routing all your read calls to your primary instance. So with the secondary preferred connection string attribute, your application with the client driver that you're using will use built-in logic to route will try to route the read traffic to the read replicas if possible, and if it cannot, then it will default back to the primary instance. So that kind of covers the first section that talks about just getting started with DocumentDB and a couple of best practices. One of the questions we often get asked from customers once they've got got the first couple of apps running is how do I scale my DocumentDB cluster? And that's a really good question. And before we talk about how you scale a DocumentDB cluster, it's important to talk about DocumentDB's cloud native architecture. So one of the differentiating abilities of DocumentDB is that compute and storage is decoupled. What this means is your storage and compute scale separately. So in the event you wanted to scale your compute up or out, you can do that without any effect to the storage layer. So in this case, as you can see, I have one primary and two replica instances, and all my instances are part of the compute layer, while the distributed storage volume that I was talking about, also known as the cluster volume, is part of the storage layer. And one of the best things about the storage volume is that it scales automatically. So if you remember, when we created our first DocumentDB cluster, we did not specify how much data we are carving out on the hardware. This is because the underlying storage service is provisioned in a way that it will scale automatically in increments of 10 gigabytes up to 64 gigabytes. So as your application grows and your data grows, the storage volume grows with absolutely no application downtime. Compute, on the other hand, you have two options. You can either scale it up or you can scale it out. And it really depends on your scenario. In some scenarios, it makes more sense to scale it up, especially if you're just trying to get more out of an existing instance. For instance, a primary instance, you're just trying to get more writes. Then you would scale your primary instance up. You can scale up individual DocumentDB instances to 24x large, which will give you 96 vCPUs and 768 gigs of RAM. And yeah, this applies to both primary and replica instances. You can also scale your read instances. You can also scale your read workload out by adding up to 15 replica instances. So every cluster can have, just to reiterate, one primary instance and up to 15 replica instances. And oftentimes we'll see customers start with one primary, one secondary, then they'll add another secondary, and then they'll add a couple more. And they typically do this is because their read workload essentially grows, the number of queries they're running increases, and they start routing it across different replica instances. One of the cool things about DocumentDB is when you're scaling your replica instances out, so let's say I'm adding a new replica instance, there is no data shuffle under the hood. So the operation's pretty fast. It takes about 8 minutes, 10 in some cases. And during the scale out process, we're adding a read replica instance. There's no impact to your cluster. So your application, while the scale out is happening, does not see any impact, which gives you the easy ability to add replica instances and remove or delete replica instances on demand. Let's actually do a couple of demos to show you, so that I can show you how this really looks like from an experience point of view. So we're going to first go ahead and scale up one of our instances, and then we're going to scale out compute by adding another replica instance. So let's go back to my console. If you go back to clusters, you'll see the two clusters we have. And I want to scale one of the instances in the cluster that I just created. So I click on the cluster, and then to do that, I have to go to the configuration tab. And under the configuration tab, you'll see all the instances that are associated to the cluster. So let's say I want to scale one of my reader instances up. So all I need to do is I need to click on that instance. I go back to configuration. I click the modify button. And now I can specify the instance class. So at create time, we had specified the R5 large, but let's say I want to scale this up to R5 extra large. I can go ahead and do that, hit continue. It gives me the option whether I would like to do this in my next maintenance window or if I want to apply this immediately. So let's say I would like to apply this immediately. I'm going to go ahead and hit that checkbox and hit modify instance. So at this point, our instance in our cluster is being updated. So if I were to go back to this instance, it's in the modifying state. Typically, we recommend that all instances in your cluster are of the same size. So if you're scaling one of your instances out, we also recommend you scale your other ones. Sorry, if you're scaling one of your instances up, we also recommend you scale one of all your other instances up as well, so that you don't have any differences in performance when connecting to one versus the other. Typically, we see customers scaling our primary instance up for bursty workloads. Let's say they're doing a migration and they need more memory for the initial load of the migration. Then they'll scale up the primary instance for a few hours, and then they'll scale it back down to save on costs. So that's typically the pattern we see when it comes to scale up. Now let's talk about scale out. So how do you scale out? Scale out, similarly, you'd go to your cluster, you'd configuration, and you'd scroll down, you see that we have 3 cluster instances. Let's say I want to add more cluster instances to distribute my read workload. I can do that by just going to add new instance, and here I'm going to go ahead and add 3 more instances and go ahead and hit create. So at this point, we're adding 3 replica instances to our DocumentDB cluster. As you can see, go back to my cluster and scroll down. As you can see, we now have around 6 instances associated with our DocDB cluster. So yeah, that's pretty much it. That's essentially how simple it is to scale out. Now let's say I realized I probably over provisioned and I only needed 3, so I can now go ahead and delete one of them. You can essentially click on that instance, and I can actually delete the instance. I have to go here. I can select the instance I want to delete, and it asks me to confirm. So I'm going to go ahead and say delete me, and I've as easily deleted an instance or scaled back down, if you may. All right, so that's essentially how scaling works in DocumentDB. Moving on, we often get asked from our customers about how they can use DocumentDB with other AWS services. And before we talk about how you can do that, it's important to talk about why you would want to do that. So AWS services are purpose-built, and that means every service serves a purpose. If you're looking for a database to enforce referential integrity, a relational database is the right fit for you. If you're looking for a database for a graph data set, a highly connected social data set, then our Neptune is the right choice for you, which is our graph database. Similarly, Elasticsearch service is the right choice if you're looking for log analytics or full text search queries. So DocumentDB is not a one-size-fits-all solution. And oftentimes it does make sense to use DocumentDB in conjunction with other AWS services. One of the tools that you can use in DocumentDB to integrate with other AWS services is chain streams. So a chain stream is essentially an ordered set of changes on your DocumentDB cluster. Chain streams allow applications to access real-time data changes. And the way to think about this is any inserts, updates, or deletes on your DocumentDB cluster will be captured in the chain stream. And once those change events are captured in the chain stream, you can replicate them to other AWS services such as Elasticsearch, Neptune, S3, etc. So yeah, it's essentially once the data is in the chain stream, we can set up a Lambda function that reads the event from the DocumentDB chain stream and replicates it to the source of your choice, which could be any of these services that you see on your screen right now. The one that I want to talk to you guys about specifically is how to use DocumentDB with the Amazon Elasticsearch service. This is a quite common scenario, and we've actually had a few customers ask us how to make this happen. And I actually have a demo to show you how this would work. But essentially, the reason customers would do this is if they want to run full text search queries over their DocumentDB data. And the Amazon Elasticsearch service is perfect for that. You can use a Lambda function to read the events from a DocumentDB chain stream and replicate them to an Elasticsearch service index. Once that data from your DocumentDB cluster is replicated onto that Elasticsearch service index, you can essentially write full text search queries on that data and essentially make the most of what Elasticsearch service has to offer. So for instance, in this example, I have an application, and let's just say my application is writing a bunch of JSON documents, which are tweets, to my DocumentDB cluster. Any insert, update, or delete is captured in a chain stream. Once that event is captured in the chain stream, I have a Lambda function that periodically runs and takes those events from that chain stream and pushes it down to an Elasticsearch service index. Once that data is in Elasticsearch, you can now use the same application to run a full text search query over the data that I was talking about. So for instance, if you're looking at tweets and if you want to do a text query on tweets where you want to just know how many people are talking about baseball, you can do that, and Elasticsearch is the right tool for that. Moving on, in addition to Elasticsearch service, you can also use DocumentDB with Glue. And for folks who don't know what Glue is, so Glue is a serverless ETL service in AWS that customers can use to essentially prepare, enrich, cook, and transform their data across various data stores and data streams. I think a couple of months ago, Glue added support for DocumentDB. And with that, you can now use Glue's Spark jobs to read, transform, and then load data from DocumentDB into other services such as S3, and or Redshift for downstream analytics. And customers might want to do this for, if they want to move data to S3, they want to do this to, carve out their data lake or build out their data lake. If customers are moving data from DocumentDB to Redshift, it's probably for warehousing purposes and or BI reporting. Our customers just like to join data across different data sources. So there's several use cases why customers want to do that, and Glue is the right tool if you would like to do that. Glue crawlers does not support DocumentDB just yet. That's something that we are looking to get some feedback on how you would like to use Glue with DocumentDB. So if that's something you're interested in doing or learning more about, feel free to get in touch with us, and I'll share email information for that towards the end of the workshop. So yeah, just an example, let's say I have an application that's writing data to my DocumentDB cluster. Once that data lands in my DocumentDB cluster, I can use Glue to read and transform the data from DocumentDB. And the reason I would like to do that is, let's say my JSON document has 300 fields, and what I really care about is just 6 of them that I would like to move to, let's say, Redshift for downstream analytics. I would use Spark to extract just those 6 fields, transform it, associate it with the data type, and then load it onto Redshift or load it onto Aurora or any other database engine for further downstream analytics. So that essentially covers what I wanted to talk about Glue. One of the other services DocumentDB integrates with is Athena. So Athena is a serverless query service that makes it really easy for customers to analyze data in S3 using SQL. It's one of the cool things about it is you pay per terabyte scanned. So it's truly serverless in the sense you don't create a server. You pay you essentially pay per query, where you pay for the amount of data you'll scan from the storage layer. Until about last year reInvent, which I believe was in November, you could only query S3 with Athena, but now with Athena's federated query feature, you can query any data source, which is really powerful because this gives you the ability to query DocumentDB using SQL. And every now and then we'll get a customer who'll ask us, hey, how do I just run a few SQL queries against my DocumentDB cluster because I'm more familiar with SQL? And the answer to that is they can now use Athena's DocumentDB connector. So this connector is now in preview. And with Amazon Athena's federated query feature, this connector enables customers to run SQL queries over their DocumentDB data. This is ideal for scenarios where you want to do 8-way joins across different data stores. Let's say you're using DocumentDB, Aurora, DynamoDB, Neptune, QLDB, name your DB, and you want to just take parts of data from these 8 different data sources and just join them. Athena is one of the better tools for that, and you can use the DocumentDB connector to connect to DocumentDB from Athena and run a SQL query. All right, now I'll show you the demo that I was talking about, which covers how to use a Lambda function to read events from a chain stream and replicate those events to an Amazon Elasticsearch index. Once that data is replicated on this index, we'll run a full text search query just to make sure that it actually worked. So first things first, I am going to launch another tool. It's called Studio 3T, and what I'm going to do is I'm going to go ahead and connect to one of my clusters. So let's say test cluster, cluster that I previously created. I've already enabled chain streams on this cluster. So the first step, if you were to do this on one of your clusters, you'd have to enable chain streams, which is an opt-in feature for DocumentDB. So once you do that, you can essentially start watching a particular collection for any change events. So I've turned on chain stream for this collection called the ES Demo Watch, which means any events on this collection, such as inserts, updates, and deletes, will be captured in the chain stream. Then I've also created another collection called ES Demo State, which will keep the state of the last processed event in the chain stream. All right, so now let's head over to Lambda. So here I have a Lambda function. It's called the DocDB Elasticsearch Replicator. What this Lambda function does is it takes any change events from my DocumentDB cluster and replicates it to an Elasticsearch index. All I have to do is run test, but before we run test, I just realized we didn't insert any data. So I'm gonna go ahead and insert some data into my collection called ES Demo Watch. And I am going to get this data set called tweets. So I'm importing 100-something tweets into my DocumentDB collection, and these are the tweets. Essentially, all tweets, or a small subset of tweets from New Year's Eve in 2014, where the fields are like the topic, who posted it, their gender, the category, the text of the tweet, ID, location, state, time zone, etc. So this is essentially the data set that I'm going to insert into my DocumentDB cluster collection. So let's go ahead and do that. I've already imported the JSON here, and I'm going to go ahead and run execute. So on the left, you'll probably see the progress. It tells me I've successfully imported 108 documents. Now, if I head over back to Lambda and if I run test, all right, seems like it signed me out. So I'm going to go ahead and sign back in. Just give me a second. All right, so here's my function, and all I need to do is run the function. So to run the function, I'm going to run test. So at this point, what's happening is our function is taking the change events from my DocumentDB cluster and replaying them on an Elasticsearch index. So the cluster that I'm targeting is this one, the test cluster, the one I previously created, and this is the URI for my Elasticsearch index, and that's the name of the index that I'm targeting. This is the name of the collection that I'm watching the events for, and this is the name of the collection that I am going to store the state of the last processed event. So if you go up, it tells me that I have successfully processed the function, and it'll tell you that we've inserted a bunch of events into the Elasticsearch index, and the last processed ID was this one. If I were to rerun the function, it will just complete quickly, and it'll tell us no events to process. And if I again just rerun it, there's again no events to process because we've already replicated all the events, and I didn't have any other inserts, updates, or deletes. So now if I go back to my Cloud9 environment, I have a few queries here. So what I want to do is I want to run a query, and a full text search query where I want to match on the text field, and I want to search for Jim. And I want to see of the 100-something tweets, how many people had something related to Jim as their New Year's resolution. So let's go ahead and copy this, and I'm gonna go ahead and run it right here. All right, so it's running our full text search query. It's successfully completed, and it kind of just printed out all the matches. And it tells me that of the 100-something, we had about 32 documents which had something related to gym, which means something related to working out. And you know, like it'll give you a score. Obviously the first result will have the highest score. If you scroll down, the score keeps going down as you know, the relevancy keeps going down. But this is a very good example where you might want to use Elasticsearch over DocumentDB, because Elasticsearch is purpose-built for running full text search queries. And if you're trying to do any sort of analytics which involves running a full text search query, then you can use chain streams to get the data replicated to Elasticsearch and run your full text search query. All right. Moving back to our slide deck. The last topic that we wanted to cover today is data modeling in DocumentDB. And before we talk about data modeling, it's important to outline a few concepts and what these concepts are in DocumentDB versus what they are in a traditional relational database. So a database, for instance, is still a database in DocumentDB. A table in a database is a collection inside a document data store like DocumentDB. A row becomes a document, a column becomes a field. A primary key is essentially an object ID, an index is an index, a view is a view. A nested table or an object is an embedded document, while an array is an array. And when we think about data modeling, again, it's very important to identify when you would use a relational data store versus a document data store, because that really impacts how you model your data. So there's different scenarios where you would want to use one over the other. For instance, if you're looking for a data store where you know your schema beforehand, before you insert your data into your database, then a relational database is probably fine for you because a relational database is schema on write. What this means is it's not trivial in a relational database to modify a schema, which is fine if you're working with a banking application or an inventory management application where the workload is transactional and the data is structured and remains fixed over time. While in a document store, it gives you the ability to have schema on read. And this means when you insert your data, which is a document, inside of a document store, you don't need to specify a schema. Every document inside of a collection could have different schema. One could have 10 fields, another could have 100, and you're not creating anything beforehand before you insert your data into your database. This works really well with certain use cases such as catalogs, profiles, content management systems, where each document is unique and the schema evolves with time. So that's something to keep in mind as you model your data for DocumentDB or any other data store for that matter of fact. The key difference here for data modeling is that for DocumentDB, we recommend customers to use the document model, which is the embedded model. And the easiest way to look at this is let's say on the left, you see an employee database with 5 tables, where you have the master employee table, and then you have permission table, the profile table, the address table, and the contact table. Each of the other tables has a foreign key relationship with the employee table, and each table essentially has its own purpose. For instance, the contact table has only information around the employee's contact, the profile has only information around the employee's profile. If you were to model this in a document data store, we would recommend that you use the document model or the embedded model, where all of this information would be captured inside of one JSON document. And tables which were previously profile, address, contact, and permissions essentially become embedded documents inside of the main JSON document. So here I have one employee whose entire data is represented in the embedded data model inside of a single JSON document. There are some benefits of this model, and the first one is that it's really easy to modify schema as your application evolves and as new query patterns emerge. Adding a new field is easy. There's no administrator actions required. One of the other added benefits is that the embedded model allows way fewer queries and updates. For instance, in our previous example, if I wanted to read or query an employee's profile, contact, and permission level and address, I can do that with a single read operation. Similarly, we can update the employee record with a new phone number and a new permissions level, also with a single write operation. So this really simplifies things, and the embedded model is much more normal to how we as humans think about data. So that's one of the benefits, that it's a fewer read operations, fewer write operations, and generally it's just a more readable data format. With that, if you have any feedback from us, if you heard about all the content for today's workshop and you saw a feature that you're looking for that DocumentDB does not support, you can email us at documentdb-feature-request@amazon.com. We monitor this email periodically and we'll make sure to get back to you as we hear from you. With that, I'll open it up to questions and answers. And thank you, everyone, for your time. We appreciate you taking time from your busy schedule to attend today's workshop.